Okay, so let's get started. Sometimes these videos don't overlap perfectly, ladies and gentlemen, so when you're watching the second video, I might go over some stuff. Let's get started with what we're going to be doing here with this information. So I want you to know here, change this to blue. These are the sets, the capital letters, correct? These are the set A, B, C, D, and E. And don't forget the universe. We need to remember what our universe is, all letters of the alphabet. So all these sets, A, B, C, D, E, exist in the universe. The universe is the max that you could have. And then, I could change my color. These are the elements within set A. These are the elements within set B, C, and D. So let's start with some here. Let's start with intersection. Oops. Let's start with intersection. And some of them I like to start with not always in order. So the intersection is where they overlap. So if I'm going to look at, how about I look at A, correct? When I do A intersect with what? A intersect with B. What are the elements that overlap in A and B? That would be just C, correct? Right? Or I could go to, how about if I say A intersect with C? Well, that's all the elements. They all share the same. So A, B, C. And we could also say that A is equal to C, correct? And there's intersection for you. How about union? Union is the next one we'll knock off there. How about if I say A, the set A, union with the set B? Remember, it's all the elements in A, all the elements in B, and all the elements they share in common. So that would be A, B, C from set A. And then what do I have overlapping? I got the C's. I don't write it twice, I only write it once. And then I can do D, E, and F. All of one, all of the other, and all where they overlap. You don't write overlapping twice, okay? So there's your union setup. And then how about cardinality? Cardinality is equal to the number of elements in a set. So if I said NC, so that's set C, correct? It's basically, that's your cardinality. It's 3. The number of elements in set C is 3. Or I could say the number of elements in B, which is 4. Or I could even do this. I could say the number of elements in C is equal to the number of elements in what? A, right? And as a matter of fact, C and A have the same thing, so I could even say A is equal to C. The set A is equal to the set C. So that's cardinality, the number of elements in a set. So that took care of cardinality. Where do I want to go now? I'm going to erase a little of this, because I don't know, I got a little room down there. How about I do complement? What was complement again that we talked about? Complement is the opposite of what's in, you're taking the complement of. So if I say complement of A, whatever is an A, we want what's not an A, that would be everything else but A for that alphabet. So it'd be D all the way to Z, correct? So how about we say D complement? So here's my D, which is X, Y, Z. And this is purposely set up this way to help you see this. The complement of D is going to be E because E has all the elements right up to W, but it doesn't have X, Y, and Z. So the complement of D is equal to E. Or I can say the complement of E is what's not in E, but's in the universe, and D has the rest of the stuff that's not in E, which is the rest of the material that's in the universe. Okay, so that took care of complement. And we already talked about what elements were, ladies and gentlemen, so we can cross that out. Subset. Let's do a subset here, and I'm going to do a little erasing. I'm not sure how to clear this out completely, so I just do it this way. So how about if I do a subset, like B? Let's take a look at B. B has 4 elements, D, E, and F. Isn't B, let's write subset. Subset. Isn't B a subset of E? Because all these elements in B exist in E, but E even has more than what B is, right? So that's a subset. It exists in E, correct? But it's also smaller than E, kind of like that A circle you see within B, or B circle in A earlier on the Venn diagrams. What else can I say? So that's subset, and they have this thing called proper subset. So I can say that A, the set A, is a subset of C. Correct? Subset means subset or equal to, called a proper subset, right? I mean, here's A, B, C, and then C is what? A, B, C, not in the same order, but it doesn't matter. I can say that only because it has the equal sign. I could not say that if you did it this way. This is a subset symbol, not a C. I could not say that. That wouldn't work for A and C, but it does here for this one. And that's what we call a proper subset. Okay. And then the empty set. Let's do an empty set. Sometimes I got to think about these. Empty set. What's an example of an empty set for you, huh? Let me think for a minute here. If I think this will work. How about if I say the set C intersect with the set D? Do they have anything in common where they overlap? Intersections where 2 streets cross. That would be an empty set. Or set notation with nothing in it. That's an empty set. There's that one. And mutually exclusive. Let me pause just for 1 minute. We'll be right back. I left off one little piece before I took the break there, and I left off mutually exclusive here. And mutually exclusive is actually C intersect with D. Even though it's the empty set, it's mutually exclusive because they don't share any elements in common. So if we took the set C, which would exist of C, little element C, B, and A, and I took the set D, which is X, Y, and Z, they were the empty set because they don't have any elements in common, and they're exclusive from each other. They're not together. They're excluded from overlapping with each other. They have no elements in common, so that's mutually exclusive. Okay, I'm going to stop the video here, and then we're going to look at the second part.